Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 4.2, Problem 5. This is Section 4.2, Problem number 5. It says, in the following table of numbers, the values in the x column represent the weights of 11 popular cars in pounds, and the values in the y column represent the average gas mileage, city and highway combined, in miles per gallon. So we have 11 cars listed, and you have weights like, 37, 65, 19 miles to the gallon average. This is a pretty heavy car, almost 4,000, gets 18 miles to the gallon. And as you see, some of the lighter cars like 2580, that's a pretty light car. Average gas mileage is 27 miles to the gallon. So as you can see, the heavier it is, the worse the gas mileage is, the lighter it is, the better the gas mileage gets, which seems, pretty intuitive. So what we want to do is draw a scatter diagram, find the linear regression equation, predict the gas mileage for a pretty heavy car, 4,400. So that's like a Lincoln Town car, small SUV type of car, or a normal car with a lot of weight in it. And then graph the linear regression equation on the scatter diagram. So let's start with the scatter diagram. So I have a scatter diagram that's started, and I have the scale evenly marked off, but I didn't label it. So what we want to do, the weights of our cars go up to almost 4,000 pounds. I can't make 4,000 little lines. I mean, I guess I could, but I really, really don't want to make 4,000 little lines. So the biggest x value is about 4,000. Go 1,000 at a time. You need 4 lines. It's probably really not enough. 500 at a time is probably a good interval for our x scale. You could go 400, and then 10 lines would be 4,000. But 500 is a nice choice. And again, you could do something other than 500 pounds per line, as long as you label it. So if I do 500, 1,000, 1,500. And I'll write them a little bit like coming down so I have room so I don't have to write it tiny, tiny. Then it'd be 2,000, 2,500. Now they don't have to start at 0 either. You could start your car weights at about 2,000. That's an option too. I started at 0. 3,000, 3,500. 4,000. That's about as big a car as we have, but there's 2 more. I might as well do 4,500 and 5,000. Especially my predicted value is going to be 4,400, so that'll be good. Now our gas mileages, or Y values, have a highest gas mileage of 27 miles per gallon. So if I have 10 lines, let's say I go 3 at a time, take us up to 30, a little past the highest gas mileage, which is fine. You don't have to end exactly at the biggest number. And again, you don't have to start at 0. Hopefully no car gets 0 miles to the gallon, but it's a sensible place to start. 3, 6, 9, 12, 15, 18, 21, 24, 27. That's as high as we have to go, but there's one more. Again, it doesn't cost you anything, 30 miles to the gallon. So let's start plotting the points. So the first car in our list weighs 3,765 pounds, gets 19 miles to the gallon. So let's go over 3,750 would be right between the 3,500 and the 4,000. So by eye, we're at about that halfway point. 19 miles to the gallon, I don't have exactly on my scale, but it's a third of the way up between 18 and 21. So there's the first car. The next one weighs almost 4,000 pounds, 3,984 pounds. It's a pretty big car, averages 18 miles to the gallon. So let's go over to the 4,000 mark on my X, and we can pull it a little tiny bit over for 3,984. By eye, it's going to be right on the 4,000. And we get 18 miles to the gallon. Be about there. The next car, 3,530 pounds, so about 3,500, and we're getting 21 miles to the gallon. So 3,500, by eye, it's going to be right on the 3,500. In reality, it's a tiny bit past it. And the height for the dot would be 21, which I do have. And the next line down, the next car, 3,175 pounds, 22 miles to the gallon. So 3,175, maybe about a third of the way past the 3,000, and 22 miles to the gallon. So past the 3,000 a little bit. 22 I don't have exactly, so I'll go about a third of the way past the 21, maybe about like that. The next car, 2,580 pounds, pretty light car, 27 miles to the gallon average, pretty good gas mileage. So for 2,580, we're going to go to the 2,500, a tiny bit past it. And the gas mileage, 27. So I do have 27 exactly here. So you can see they're starting to line up in a pretty straight line, fairly linear, the relationship. The next car, 3,730, 18 miles to the gallon. So 3,750 would be exactly between the 3,500 and 4,000. So 3,730 is pretty much right there. 18 miles to the gallon. That's a pretty crowded area. The next one, 2,605 for the weight. So 2,605, a little past 2,500. The gas mileage is 26 miles to the gallon. So almost up to the 27, 2/3 of the way up. And next one down, 3,772 for the weight, so almost 3,750 in terms of what it's close to on my graph, and up 17. So 3,750 would be between the 3,500 and the 4,000, so it's pretty close there. 18. The next one, 2,605, and it's up 26. So 2,605 is a little bit past the 2,500, and it's up 26 miles to the gallon, so almost to the 27. And just a few more. 3,772, so it's pretty close to 3,750. And the gas mileage is 18. We have another dot right about in there. So this is really getting crowded in that area. And let's see, the next one is 3,310. So 3,310, so between the 3,000 and the 3,500, close to the 3,500. And our gas mileage is 20. So I have 21. So right about there. And now two more, 2,991 for the weight. That's pretty close to 3,000, so by eye we'll say 3,000. And the gas mileage is 25, so I have 24, 25. And finally one more, 2,752. So 2,750 is right between 2,500 and 3,000. So by eye, it's right at that in-between point. The gas mileage is 26, so not quite 27. So they're kind of clustered right around here. It does look like it's coming down as you go from left to right. The heavier the car, the lower the gas mileage. So that's the first one, a little bit tedious. The second one, find the linear regression equation. So find the y equals a plus bx equation. It's a 5-step process. Step 1, fill in the chart. So I'll put the chart right underneath. Let's give myself a little bit more room. The x values are the weights. Y. X times y, and then x second power. So the x values, just copy right from the question. I happen to have them written down. So the x's, the weights of the car. The first car was 3,765 pounds. The next car was 3,984 pounds. The next one was 3,530 pounds, then 3,175 pounds, then 2,580 pounds, 3,730 pounds, 2,605 pounds, 3,772 pounds, 3,310 pounds, 2,991 pounds, and finally 2,752 pounds. Those are the weights of the 11 cars. Now the average gas mileage that each one got, the first car 19 miles to the gallon, then 18 miles to the gallon, 21 miles to the gallon, 22 miles to the gallon, 27 miles to the gallon, 18 miles to the gallon, 26 miles to the gallon, 17 miles to the gallon, 20 miles to the gallon, 25 miles to the gallon, and 26 miles to the gallon. So there's the first two columns filled in. The next column we have to do x times y. So these numbers will get fairly big. Definitely something you want to use a calculator for. This whole problem can be done with software, actually. So x times y, you're going to go 3,765 times 19. The result of that is 71,535. The next car, the weight of 3,984 times the gas mileage of 18 miles to the gallon gives you a result of 71,712. The third car, the weight of 3,530 times the gas mileage of 21 miles to the gallon gives you a result of 74,130. The next car, the weight is 3,175 times the gas mileage of 22 miles to the gallon. When you multiply, you'll get 69,850. And the next car, the weight is 2,580 times 27 miles to the gallon is 69,660. And the next car, the weight is 3,730 times the gas mileage of 18. When you multiply that out, it's 67,140. And the next one down, 2,605 for the weight times 26 miles to the gallon for the gas mileage is 67,730. And the next one, the weight is 3,772 times the gas mileage of 17 miles to the gallon. That multiplies to 64,124. The next one is 3,310 for the weight times 20 for the 20 miles to the gallon is 66,200. And then the next one is 2991 times the gas mileage of 25 miles to the gallon. If you multiply that out, it's 74,775. And finally, the last car is 2752 for the weight times 26 miles to the gallon for the gas mileage, and that multiplication comes out to 71,552. So one more column, x to the second power. These numbers will get pretty big. X is the weights of the car. So we'll have 3,765 for the first value of x second power. So 3,765 times 3,765 is 14175,225. The next car, the weight is 3,984. So you'll do that to the second power. So 3,984 times 3,984 is 1,587,226. The next car is 3,530 for the weight. So you do 3,530 second power. 3,530 times 3,530 is 1,246,0900. The next value of x is 3,175. So you do 3175 second power. 3175 times 3175 is 100,80625. And then 2580 second power. So 2580 times 2580 is 6656400. And the next car, the weight is 3730, so you do that second power. 3730 times 3730 gives me 1391290. And then the next car, the fairly light one there, 2605. So second power, so 2605 times 2605 is 678025. Then the next car is 3772 for its weight, so you do second power. 3772 times 3772 is 1422984. Then just a few more left. 3310 is the next weight. So 3310 second power. 3310 times 3310 is 109,56100. Two left. So 2991 for the weight of the car. So you raise that to the second power. 2991 times 2991 will give me 894,6081. And finally, one last car, the weight of 2752. So you do second power for that. 2752 times 2752 gives me a result of 75,73504. So that's step one, fill out the chart. That's quite a lot of work. Most of this I had already calculated before, so just writing it out, copying what I had, took a good amount of time. The second step, get a total for each column. So the X column, if you add up the weights of all these cars, I have the total written out already, it's 36,194. 36,194. Get a total for the Y column, add up all the gas mileages. The Y column, the total is 239. Then X times Y, if you add all these big numbers, 70,000 something for most of them, it comes up to 768,408. And then the last one, the X squared, is a really big number. It's going to be 1,216,4,8,0,0,0. So that's 121,648,000. So that's step two. Step two is get a total for each column. So you totaled it up. Again, this would be a good amount of work. Step three, fill in the formula for B and get an answer for B. So the formula for B is B equals total of X times Y minus total of X times total of Y over N. Then underneath, total of the X squares minus total of the X's squared over N. That's the formula for B. Again, the parts in the denominator look so very similar. They both have total of X squares, but the parentheses are different. The first one, you do the X squares first, then do the total. And then you have the same parts, but the parentheses are grouped differently. The total of symbol is inside the parentheses. You get the total first, then do the second power. So start filling it in. Here's where you really want to be careful. B equals. So first, total of X times Y. I have an X times Y column. The total is 768,408. That's total of X times Y. Then minus total of x times total of y. So total of x, total of all the car weights is 36,194 pounds. Times total of y, total of all the gas mileages, my y column. Total is 239. That'll also be over 11. 11 is how many data points you have. In this case, it's 11. They tested 11 cars to compare the weights and the gas mileages. Then in the denominator, total of the x squares, where the second power is inside the parentheses. You do the second power first, then do the total afterwards. So where we've done the second powers first, then we got the total. The total is that 121 million number, so 121,648,000. So that's total of the x squares minus then total of the x's squared. So the total of symbol is inside the parentheses. You get the total first of the x's, that's the 36,194. Then you're going to do a second power. So it's going to be 36,194 second power. And underneath n, number of data points, 11. That fills in the formula. So now we have to start the computation. Again, the numbers are pretty big, but they'll simplify down to something as we make some progress. So now the first thing I want to do is do the multiplication. So the first step, I'm going to multiply 36,194 times 239. I'll leave the other stuff. And underneath 36,194 times 36,194. So to do that, the 768,408 will stay for a minute. Now, 36,194 times 239, I have written down here. And that number comes out to 8650366. The 11 will stay underneath. Then in the denominator, you're going to have 121,648,000. That'll stay for a minute. Minus 36,194 times 36,194, which is a really big number. It's 131,005,636. Also over 11. So the numbers are getting pretty big now. So on the next step, I'll divide the 11s. And then I'll just have two numbers in the numerator, two numbers in the denominator. Then I'll do the subtractions. So we're going to have 768,408 minus. When I divide 8650366 by 11, that result comes out to 786,396.9091. I'll leave the decimals for a minute. I'll round them off in just a sec. In the denominator, the 121 million will stay for a minute. 121,648,000 minus. So this big 131,000,5636 divided by 11. The result of that is 119,091,421.5. So now, all I have to do to finish B is do the subtraction in the top, do the subtraction in the denominator, and actually do the division. So now when I subtract the top, 768,408 minus 786,396.9091, the result of that is a negative 17988.909. And then the next one down, when I do 121,648,000 minus 119,091,421.5. Now the calculator actually had a few more digits here, so when I do the subtraction, there's going to be a couple of more digits that will show up. the denominator will give me a positive 2556578.546. So now to finally finish off the value for b, I'm going to do b equals negative 17988.90909 divide by, you'll definitely have to do this with a calculator, positive 2556578.546. And the calculator is going to tell you that's negative 0.007036321,696. I definitely don't want that many decimals. Let's round it off a little bit. Negative 0.007. The fourth digit out is a 0. It's not really big enough to make it a negative 0.008. So we'll stop it at negative 0.007. So we're letting some of these digits run off. So now that we found b, the next step is to find a. So a equals total of the y values over n, which I've written in my chart over there, minus b, this b that we just found, times total of the x values over n. So now a equals total of the y values, total of all the gas mileages, that total is 239. And divide by n, n is 11. Minus b, the b that we just found, is negative 0.007. Notice two negatives, one negative from the formula for a, one negative from the fact that the value of b is negative. Then total of x's, that's the total of all the weights of all the vehicles, which was 36,194 pounds. The total of the x's over n, n is 11. So now this is going to give me a because I want y equals a plus bx. Now that I have the formula filled in, let's do the divisions. So a equals 239 divided by 11 is 21.73. This minus a minus, again the two minuses, one minus from the formula for a, the other minus because b is a negative value. They're going to cancel and become a plus. 0.007 times 36,194 divided by 11. That comes out to 3290.36. So now we have an addition and a multiplication to do. The order of operations say we have to do the multiplication first. Get an answer for the multiplication first, then I can do the addition. So a equals 21.73 plus, when I multiply 0.007 times 3290.36, that comes out to 23.04. And now finally to finish a, if I had 21.73 plus 23.04, the value for a is 44.77. So now I found b, negative 0.007. I found a, 44.77. So let's come back to where I have a little bit of room. So the final step, write your solution in the form y equals a plus bx. So y equals a was 44.77 plus b was negative 0.007 and then x. And that plus a negative, the plus comes from the y equals a plus bx, but b is a negative value. The plus and the negative together, we can simplify that to just be a negative. So my linear regression equation for this problem is y equals 44.77 minus 0.007 times x. With that equation, if you know the weight of the car, you can make a reasonable prediction as to what the gas mileage is. Now, when I say the weight of the car is you leave a lot of extra junk in your car that you don't need, you are pulling down the gas mileage. So this was just part B, find y equals a plus bx. Part A was draw the scatter diagram. Part B was find y equals a plus bx, and we did all the work. And because there were such big numbers and we had 11 data points, 11 cars, it's a lot of work. But now that we have it, making the predictions for the weight is fairly easy. So part C is predict the gas mileage for a car that weighs 4,400 pounds. That's a big full-size luxury car, like I say, Lincoln Town Car sort of a car. Put in the 4,400 for x. So you're going to do y equals 44.77 minus 0.007 times x becomes 0.007 times 4,400, the weight of the car we want to predict the gas mileage for. So again, you have a subtraction and a multiply. You must do the multiply first. That's the order of operations, then do your subtraction. So y equals, leave the 44.7 minus for a minute. 0.007 times 4,400 comes out to 30.8. So for all the crazy decimals that we had, it's toning down not too bad. And now if you do 44.77 minus 30.8, you get a predicted gas mileage of 13.97. So if you have a car so big that it weighs 4,400 pounds, the linear regression equation predicts that your average gas mileage, city and highway combined, will be within some type of sensible round off, about 14 miles to the gallon. It's kind of low. Spend a lot on gas. So the final part is draw the y equals a plus bx equation, 44.77 minus 0.007x, on the scatter diagram. And what you're going to see is it's going to go through these lines the best possible fit. So the graph is going to be a straight line. To graph a straight line, we need 2 points. 1 point we already figured out. So if we put in an x value of 4,400, we get a predicted y value within some type of sensible round off of 14. By I on the graph is going to be 14. So there's 1 point. I can go ahead and put that point in. If I get one more point, I'll have 2 points. I can connect them, get my straight line. To pick up my second point, I can just randomly, arbitrarily pick a different value for x, a different weight for the car. Say put in an even 3,000. It'd be easy enough to calculate. Get the gas mileage for my 3,000 pound car. I'd have a second point. Put the 2 points on my graph, connect them, I have the line. That would be easy enough. But from the explanation in the notes, it mentions that x bar, y bar is always, always, always a point on the graph. Let's see if I can just squeak it in here. X bar, y bar is always, always, always a point on the graph of the linear regression line. So that x bar is a total of the x values over n. The y bar, or average of the y values, total of the y values over n. And if you hadn't already done the computation, that's actually more work than just picking a different point like a 3,000 pound car and finding the gas mileage like we did here. But because we computed A, I happen to have total of the x values over n. It was 36,194 over 11, and we did that work. So the x coordinate is 3290.36. We don't really need the 0.36. We can round it off in terms of the graph. Average of the y values, or total of the y values over n. Oh, look, total of the y values over n. I did it like 2 minutes ago. It's 239 over 11. I did the division. It came out to 21.73. And in terms of our graph, I'll just hit the graph at a height of 22, just to, graph it. So we have 1 point over 4,400 up 14, and we have a second point over 3,290 up almost 22. Give me my 2 points, I'll connect them, and I'll have the graph of my y equals a plus bx equation. So the first one, 4,400 for the x, 14 for the y. And I do it in a different color. I want to do it in blue because there's already so much red. My 2 extra points are just going to get lost in this jungle of red points. So over 4,400 is 45. 4,400 would be about here. Up 14, so there's 15. 14 is about here. So if I intersect my horizontal 4,400, my vertical 14 comes about here. And as I expect, it looks pretty in line with the red points. The second point for the graph of my linear equation is going to be over 3,290. So between 3,000 and 3,500 is 3250. So 3290 is going to be approximately halfway between 3000 and 3500, slightly further right. The height for that, 21.73. So here's 21, 22 is about here, 21.73. So I'll intersect this horizontal with that vertical. And again, it winds up in the red, which is what I expect. And now we'll connect those with a straight line. I have my 2 points. And again, if the graph was a curve, I'd need a lot more than 2 points. But because it's a straight line, 2 is enough. So there's the graph of the linear regression equation that we found. So that blue line is the graph of y equals 44.77 minus 0.007x. That's the line that we graphed on the scatter diagram.